A gallon of milk weighs 3,900 grams, give or take a little depending on the milk fat content. Wonder if this would float in water. Well, if a gallon of milk is lighter than a gallon of water, which weighs about 8 pounds, then it will float in water. So what is the weight of that milk in pounds? Is there a way to convert grams into pounds? There is a way, and chemistry students use this technique all the time. It's called dimensional analysis, and I'll teach you this strategy using a few examples. In order to convert from grams to pounds, we'll use a conversion factor. A conversion factor is a set of values that represent the same amount, but they have different labels. For example, 60 seconds is the same amount of time as 1 minute. You probably already know a lot of conversion factors, like 12 inches is equivalent to 1 foot. And there are 100 cents in $1. There are a lot of other conversion factors. Some you'll probably have memorized, while others you can look up in a table. Here are a few. See how many you already know. There are exactly 1,000 grams in a kilogram by definition. And 1,000,000 grams are equal to a megagram. A gram is equivalent to 100 centigrams, and it is also equal to 1,000 milligrams. Micrograms are tiny units, so it takes 1,000,000 micrograms to equal 1 gram. An even tinier unit is the nanogram. There are 1 billion nanograms in a gram. These metric prefixes are extremely useful because they work with grams, meters, liters, and any other units. These conversion factors are all based on the metric system. But what about the US, where we're accustomed to different units? Here, we measure our distances using the mile, which measures approximately 1.609 kilometers. A gallon, the unit we use for volume, is equivalent to about 3.785 liters. 1 pound is equivalent to approximately 0.454 kilograms, and an inch is defined as exactly 2.54 centimeters. Notice that these conversions, with the exception of the centimeter-inch conversion, are all measured values, so the rules for counting significant digits will apply. Now, let's try to solve a simple conversion problem using the technique known as dimensional analysis. Joey has 804 minutes of music on his iPod. How many hours will this last? To begin this problem, we write the given, 804 minutes, as a fraction. In other words, I'm writing 804 minutes over 1. Now I know that 60 minutes is equal to 1 hour, so I'm going to write this conversion factor as a fraction and multiply the two terms. The only question is, should I write the 60 minutes on the top of the fraction, or should I put it on the bottom? If I put 60 minutes on the top and then multiply these two terms, I'll end up with units of minutes times minutes per hour. Not what I was looking for. If, however, I set up my conversion with 60 minutes on the bottom, then the product of these terms results in units of hours. Just what I was looking for. So the answer to this conversion is 804 over 60, or 804 divided by 60, which is 13.4 hours. Does this answer make sense? Could someone have a day's worth of music on an iPod? Sure. Let's try another. You are training for a 10K race. How many miles will you be running in that race? In this problem, what is the given information? Right, 10 kilometers. Just like before, I'll start by writing the given over 1. Now, I'll see what conversion factors I can use. How about 1 mile equals 1.609 kilometers? Now, in order to get the kilometers in my given to cancel, I see how I must arrange that ratio. I put 1 mile on the top and the 1.609 kilometers on the bottom so that the kilometers cancel. This means to get my answer, I should divide 10 by 1.609, and the answer is 6.215 miles. So, back to our gallon of milk. We want to convert 3,900 grams into pounds. To solve this problem, let's start by writing down what we know, or the given, as a fraction. That's 3,900 grams over 1. Notice that we always include the units, or the dimensions, since we are analyzing the dimensions to solve this problem. Next, we insert a conversion factor that will cancel these units. I don't have a conversion factor that goes from grams to pounds. I do have a conversion factor that goes from kilograms to pounds. I'll just have to turn grams into kilograms first, and then convert those into pounds. A quick check of my units confirms that they all cancel, leaving me with pounds. The setup for this calculation shows me that I must divide 3,900 by 1,000 and 0.454 to get my answer, 8.59 pounds. So a gallon of milk weighs 8.59 pounds. A gallon of water weighs 8.35 pounds, so the milk will sink. Don't believe me? Try it.